Now, this is the second math class from SAT. And welcome everyone who is watching this video. Now, I remind you that I cover topics very fast, so that's why I need your attention all the way from the start till the end of this video lesson. And please watch it carefully without skipping any part, because I'll be giving a lot of information in this class. So without further ado, let's start off. In this lesson, we're gonna learn advanced math from SAT. As the name suggests, it is advanced, so it naturally seems to you a little bit difficult, complex in comparison to ordinary math that you may encounter in your school. As you can read here, advanced math in simple terms means math is about understanding and transforming more sophisticated mathematical terms. These are linear relationships and recognizing patterns like statistics, and you gotta also be familiar with algebraic techniques, strategies, and many more that we're gonna cover. And yeah, there is a possibility of 35% possibility that you will have advancements, which is relatively high. That's why just pay attention. Today's agenda is, as you can see, a lot of stuff here. It may seem to you 4 things only, but within function itself, there are a lot of subcategories which require you a lot of attention, and it requires a lot of time. So due to this, I believe that I could separate this lesson into 2 videos, since that's gonna be too long if I record it in one video. Anyways, let's give it a shot. So first thing that we're gonna cover is functions. So what is a function? I would like you to imagine a function as a factory, and that's why I equalize these two. Function equals to factory. You may say, why? How? Any number, any variable in this case, you put into factory, which is x, you'll get the result all the time in y. That's it. That's the whole thing that you want to learn. You obviously gonna calculate anything that you put into the factory, and the result will be the end product of it. Let's say you put raw material, you'll get the end product, ready product. Let's say in this case, f of x equals to 2x plus 2. And also I want to note that f of x, in other words, equals to y. So they are interchangeable. It's just a fancy way of saying y. They just prefer, SAT prefers to say f of x instead of y equals to something. So this is just a simple ordinary linear equation that you have to know. To find out, actually you don't necessarily have to find out, it's just an example because there is no any description, any question for it. But this is how you gotta learn. So this is the x values, this is the products, basically, let's say items in the factory, and this is the end product that you get. Now, you gotta know a couple more rules and regulation about functions. So in function, we have x and y plane. All the time, x-axis goes to horizontal and y-axis goes vertical. And we have 4 separate quadrants. As you can see, quadrant 1, 2, 3, and 4. Just learn this order. You can't mix this. You can't start from there or there. So this is the order, standard order that you must be familiar with. Because there may be some questions which require in which sector or in which quadrant the solutions lie. That's why you gotta know this. And we have our x and y value. And we have also points with the help of which we can construct a line in the graph. For example, let's take this point. So we've got 2 for x and 1 for y. All the time it is important to remember that first number comes x, then y here. See, in order, x and y, as it sounds. All the time, here it is, x and y, not y and x. That's why in xy plane we also look for first x value, then y value, if you see it in this kind of number. Now, we have also table version of it, as you can see there, with the help of which you can also construct this linear function, just a function, and you can construct this and put those numbers to see the basic line where they intersect. We also have mapping version. Minus x goes to 2, which means like minus minus 3x, sorry, here, and 2 is there about. That's gonna point gonna be there approximately. So the same thing with other numbers as well. Moving on. Here are some examples that I would like to solve with you. So let's solve second example. Some values of a linear function f are shown in table above. Which of the following defines f? Here, what we're gonna do, for that, we gotta know slope. But since we didn't cover yet, let's skip this for now. Let's look at seventh question. So it says, a system of inequalities and a graph are shown above. Which section or sections of the graph could represent all the solutions to the given of equation? We need the best optimal and fast way of solving it would be with the help of Desmos. Why? Because we don't see any points there, we don't see any number. That's why it is hard for us to guess whether it's 1 or 10. That's why I just put this into the Desmos and see in which sector or sectors the graph represents the solution, basically. Well, let me open the Desmos. As you can see, I typed everything into Desmos, and from there you can see that, bear in mind that our solution lies on the point of intersection of two lines, two colors in this case. So where you see the intersection of both colors? Only in this section, right? So that sector called sector A based on this interpretation. So other parts we are not interested because there is no solution. That's why solution A, option A is correct. We're gonna cover in next slides about these equations, but for now, that's how we solve it. Now we're stepping into one of the important topics in SAT, which is parallel and perpendicular lines. So starting off with the first example here, you can see they're intersecting. It means they're intersecting lines. These lines, they are equal to each other, but not touching to each other, which means they're parallel. If lines are parallel, they have the same slope, but they don't intersect in any point. That's the information that we're gonna know. And for perpendicular lines, they all the time intersect at 90 degrees. So if you were to draw an angle there, you'll get 90 in every side, because that's the rule of it. And there's another thing that you gotta know, which says change the sign and flip the slope, which I'm gonna show with an example. It would be better to understand with an example. Also, we have certain scenarios when you type it into Desmos, like here I typed there, but with just equal sign, you'll get lines there and see they're intersecting once, as it's written here. They're intersecting once, which means they have only one solution. Their slope are different, as you can see there, and they intersect at one point. They have solution only there. We don't care about this line, we don't care about that line. No, we only care about point of intersection. This is how we find out the solution. And the second scenario says that if lines are parallel, they got the same slope, and they never intersect at any point, which means there's no intersection. You're just gonna memorize these things. I'll show you with example again. It gets better understandable for you. And third scenario, you will see infinitely many solutions, and in that case, both lines intersect on each other. Here you may not see this, but line red lies below this line. And in this case, there is infinitely many solutions. Now moving on, let me start briefly show you examples, what I mean by this. As you can see there, I've got 3 examples for myself, and I want to show you with the help of Desmos the concepts that I explained beforehand. So the first case, you see I typed everything correct, and you see that in XY plane there is only one intersection where we've got different numbers, which is not important, but the important part here is the point of intersection. They are intersecting, which means that based on the rule that we covered, there is only one solution. In the second one, without putting into Desmos, you can see that they have the same slope. Maybe it may be early for you to know what is the slope. The slope is basically y equals to mx plus b. Slope is m. but we're gonna cover it in later topics. But if you type these two in the Desmos, which I'm gonna do right now, you will see that they don't intercept in any point. Let me illustrate it. Plus 7. See, the two lines are parallel, and regardless how you scroll, whether up or down, they won't ever cross. This is the rule. They basically obey that rule. And third scenario, so basically in this case, we have how many? 0 solution, because they don't intercept. In third case, let me just type into Desmos 4. I missed y there. There's one, sorry, there are basically you can't see a black line, which means it's already in it. It's already included. Red line is overlapping with black one. If you switch off it, you'll see that they're perfectly matching, which means there is infinitely many solutions. That's how we prove that concept that we learned. And the next thing that we're gonna cover is slope, domain versus range. So basically, we're gonna cover slope. As I talked in previous, a little bit earlier, I talked about slope. So now it's time to learn about slope. Basically, before that, we gotta be familiar with terminology of domain and range. Domain is a set of ordered x coordinates. Range is the arrangement of y coordinates. That's the thing that you're gonna memorize. That's it. There's nothing to complain about it. When it comes to slope, though, slope is just a rate of change. Consider slope as a rate of change. That's it. That's all what you have to know about slope. It is the way how your line goes up or down. It's like a speed at which your line goes up and down. So in first case scenario, you'll see the positive slope because this line goes from there to up to there. It goes to infinity. This is a positive. This one is negative because it starts from there, goes down. This has a 0 slope because it never touches x coordinate. It only lies from y coordinate. This slope is undefined because it goes from vertically. It goes in only touches x coordinate. Let me go to the next slide. Here you see 3 different scenarios, 3 different formulas that you're gonna memorize. First one is ax plus by equals to c. This is the standard form of linear equation. I can show you with example later on. This is just the standard form where you can see it into the primitive, very normal form. And in slope intercept, it is y equals to mx plus b. So why do we need this? We need it because when we want to see y coordinates. It may be confusing for you. I'm going to show with example there. And slope point form for us to find out one of these which is missing there. So let's say we are given 2 points and we gotta find slope, or we are given slope 1 point, we gotta find another point. We need this formula. And you see that, in other words, x coordinate would be prefaced as run, and y coordinate is rise because it's rising from the ground. And usually we have another formula which I missed, I believe. It looks like, let me illustrate it here. That formula looks like this: y minus y1 over x2 minus x1. This is the formula of slope. To find out slope, which means m, let me put m there, not to confuse things. It is m, consider it as m. I got very bold pen here, but anyways, let's just imagine that this one is m. So to find out m, we implement this formula, which means that we pick 2 y values. Let's say we've got this y value and that y value, and subtract from each other, divide this subtraction by these 2 x values. We pick from there, and we divide these things to find out slope. It may get clear when you try to solve equations with examples. It may be a little bit confusing for you, I understand. I experienced the same case, but anyways, try to digest it for now, and we are moving to examples. These are the examples for you to check whether the lines, the following equations, represent parallel line or perpendicular line, or neither. You may check for yourself by putting them into Desmos, but I'm gonna go back here and explain some examples for this one. So let's say we've got one point where we have, let's say this one is 3 for x, and this one is, I don't know, let's say 3 for y. Then I've got, let's say 13 for x, then let's say 7 for y. So you see there's 1y, 2y, 1x. Now what we have to do is we gotta find the slope from this line. What is the slope of this line? If you are asked what is the slope of this line, we gotta put into this formula. There is 1y, so we write it here, and there is another y, which is 3, okay, and we divide it by the subtraction of these two lines. 13 minus 10, sorry, 3. That will be 4 over 10, or if you simplify this, 2 over 5. This is the slope of this line, which means that you can put 2.5 over 5 instead of m. That's gonna look like this, 2 over 5 plus b. Now, since we have two variables here, it's usually not good. We gotta have only one variable, which is y, into the left side, because you remember that I talked about factory, and functions are factories. So y value is the result of it, and x value is the calculations, anything that you put into function. I missed x there, my bad. There must be x based on this formula. Now, to find out, to simplify things, we have to find out b here. We can also find out y, but it doesn't help us. So it's better to find out b there. To find out b, we get either this point or that point, doesn't matter, it's up to you. Let's get that point. For 3 for x, we put 3 there instead of x, and 3 for y. If you put 3 there, you'll have 2 over 3 multiplied by 3, and if you put 3 instead of y, you'll get 3 equals to 2 over 3 multiplied by 3 plus b. So from there, it must be easy for you to find out b. This 2 will cancel, then you will get 2, and if you subtract 2 from both sides, you'll get b equals to 1. This is our equation. So you'll put 1 instead of b, and that's gonna look like this. This is our complete equation. So based on this form, you can convert it into standard form by sending x and y to the one side and c value to the another side, which means that if you try to convert it into standard form, it will be like minus plus y equals to 1, because we subtract this equation from both sides and we'll get this result. This is in standard form, as you can see. This is our a, this is a b value, this is our c. Now you want to put into slope point form. Let me put it in the slope point, but for that let me erase some parts. Now for y, pay attention that we don't put any variable from here. We just put how it is. We just write y minus, pay attention to the sign, you can't put plus there as long as it is not minus in this equation. Let's say it's minus 1, then if you put minus 1 there, 2 minus will be plus, but it's not the point. The point is, in this case, if you get 3 there, it will be 3 minus 3, that equals to, our slope was 2 over 5, if you remember. We write it 2 over 5. Our x, we don't put anything instead of x, but for x1, we'll put whatever 3, and we put 3 there. This is how we put in the slope point form. That's about it. So we're gonna finish our lesson right there. And from the next lesson, I'll be covering other remaining topics. These are the examples that you have to check. That's about it. Thanks for watching. Take care. Have a nice day.